All right, let's take a look at complex fractions. A complex fraction is a fraction that has other fractions inside of it. So we look at this when we're talking about rational expressions. So there are two kinds of complex fractions essentially. The first kind, the easier kind, is if I just have a fraction made up of two other fractions. This is easier because, of course, fractions represent division, so this problem really just means that I have negative 3d squared plus 11d plus 20 over 6d to the fifth divided by 3d plus 4 over 2d cubed. And since this is division, we know that with a division problem we can change this into multiplication. So I will do just that. And I'll try and make my handwriting a little bit neater. And then what we would try and do, of course, for a problem like this is factor any numerators and denominators and try and divide out common factors. Well, most of this, this is a pretty simple example. Most of this does not require any factoring. 3d plus 4 is its own factor. 6d to the fifth, 2d cubed. Those are essentially factored because they're just constants times powers of d. Up here I do have a polynomial that I need to factor, though. If you take out a leading negative, you'll be left with 3d squared minus 11d minus 20. Think about that for a second. What is that? Negative 3d squared minus 11d minus 20. So then I would need factors of negative 60 that add to negative 11, which is negative 15 and positive 4. So that means I would need those as my factors. So if I factor this, what I get is right here. And then, as I would for any simplifying, multiplying, dividing problem, I look for common factors which I can divide out. So I can see that I have a 3d plus 4 as a common factor, and I can divide that out. Notice that negative is still there, though. And d minus 5, I can't do anything with that. 2 and 6 I can simplify, leave me with a 3 down here. And d cubed and d to the fifth, well, I can simplify that and be left with d squared. So what am I left with? My final answer should be, up on top I have a negative and d minus 5, and I can write it like that, or I could apply the negative, I could distribute the negative and make it negative d plus 5. And in the denominator I have 3d squared. Now again, we'll talk about restrictions, although restrictions are sort of less important for complex fractions. Based on the original denominators, I can see here and here, d was in the denominator, so d cannot be 0. And be careful here as you do this, because this gets a little confusing. 3d plus 4 was also in the denominator. So if 3d plus 4 were to equal 0, or if I want the 0 of that factor rather, d cannot be negative 4/3. So those are the only restrictions for this particular complex fraction. Now, like I said, this is the simple example. If you ever have this, this is the easiest way to tackle it. More challenging examples, and you will see these, are what if I have something that has multiple terms inside the fraction and or that even requires more factoring? Well, I have two options. One thing would be to add these two expressions down here so that I have something more like our previous example where I just have a quotient of two fractions. And that can be done, but the truth is it's actually a really slow process. So what I instead want to do is this. I want to think about the LCD of all the denominators inside of this fraction. Now, in order to do that, what I need to do is first factor y squared minus 9. And y squared minus 9, that's pretty simple. That's y plus 3, y minus 3. Okay? So my LCD then, I see the denominators are y plus 3, y minus 3, and y plus 3. So my LCD has to be divisible by both of those denominators, which means it should be y plus 3, y minus 3. So now, what am I going to do? Well, what I'm going to do, and I'm going to show you this in a couple steps before I just start doing it. What I'm going to do is multiply the numerator and the denominator of this complex fraction by that LCD. I can do this because I'm multiplying by 1. Now let's think about how this would work. Up top, I'm going to multiply this one expression by y plus 3 times y minus 3, and in the denominator, I'm going to multiply both 1 and 5 over y plus 3 by y plus 3 times y minus 3. So we'll write that out. It really doesn't matter if you write this on the right or the left. I tend to switch it up for I don't even know what reason. So 2y plus 1 over y plus 3 y minus 3 is going to be multiplied by y plus 3 y minus 3. In the denominator, again, each of these terms in the denominator is going to be multiplied by that LCD. Okay, now that looks really cumbersome, but here's the idea. If you think back to what we've been talking about with LCD and factors that are missing or needed, the whole idea is when I multiply this, what I'm going to be allowed to do is eliminate the denominators inside of this expression. You can put this over 1 if it helps you. You don't really need to, but you can if you want to. And what do I see up here? Well, I can cross-simplify these common factors. And I will be left with simply 2y plus 1 in the numerator. Move this over a little bit. Down here, well, there are no denominators to simplify with this. Over here, I can simplify the y plus 3's. All right, so then what am I left with? This is 1 times y plus 3 times y minus 3, which we know already is, pause for a second. What I'm going to do here now is multiply this out. Okay, so this is 1 times y plus 3 times y minus 3, or 1 times y squared minus 9. Down here, I have 5 times y minus 3. I need to multiply this out, and then I'm going to look to factor it. If I multiply this out, I will have y squared minus 9 plus 5y minus 15. If I combine those, what I get is y squared plus 5y minus 24. Now I can factor that denominator. What do I get? Well, what multiplies to negative 24 adds to 5? The answer is plus 8 and negative 3. So y plus 8, y minus 3 are my factors. Just as with adding, subtracting, or simplifying, multiplying, dividing, I would look to simplify this now, but I can see 2y plus 1 is its own factor, and it's not common to the denominator. So this is my simplest form of my answer. So this is really the best way to tackle most complex fractions. It's the way it's expected to be done by your pre-calc teachers next year. And that's what I get. Now again, if I'm thinking about restrictions, think back to everything that was in the denominator, including your original LCD. From this LCD, y could not be negative 3 or positive 3. And as I went through this, I got this extra restriction. Right there, this other factor, y plus 8, popped up, so y can also not equal negative 8. All right, let's take a look at another example. This one is actually a bit simpler, because my denominator is very simply, the denominators inside the complex fraction is very simply just p minus 6. So my LCD is just that, p minus 6. Now I'm going to condense my work a little bit more, because going back to this problem, you see I did write out a fair bit of work. The idea is to multiply it into both the numerator and the denominator, and in that process to multiply it to each of these terms inside. So what I will have is 4p over p minus 6 times p minus 6 over 5p minus 7 over p minus 6 times p minus 6 minus 3 times p minus 6. Now again, the idea of this is allows me to eliminate these denominators. The p minus 6's are gone, and I'm left with, up top, that is simply 4p. In the denominator, be careful about what this is. You have 5p minus 7, and down here you're distributing negative 3 to p minus 6, so that's negative 3p, minus 3p plus 18. So my denominator then is 2p plus 11. So this really nasty looking ugly thing that I started with is equivalent to just 4p over 2p plus 11, provided, what restrictions do I have? Well, based on the original LCD, p could not be 6. Based on this new denominator, the 0 of this factor, 2p plus 11, is negative 11 halves. So don't forget those restrictions because those will be useful from time to time. Okay. Now, let's take a look at some more examples. Now, by the way, these are just some examples. This is by no means a comprehensive list. I notice as I'm looking at my examples that for some reason all of them have 2 terms in the denominator, which that by no means has to be the case always. But again, you're supposed to get the general idea from this. If I look at the denominators inside this expression, I can see I have x and 3x squared. Well, x is a factor of 3x squared, so my LCD can just be 3x squared. And again, I'm going to multiply it to each of these terms. 1, 3 over x, 2, and 10x plus 4 over 3x squared. Excuse me. Alright, and now what I'm looking to do is to simplify all the denominators inside my expression. So this x can be simplified with x squared to leave me with just x. 3x squared can be simplified with 3x squared, and I'll be left with nothing. So what do I have? Up top, I have 3x squared minus 3 times 3, which is 9. In the denominator, I have 6x squared, and be careful here, I'm subtracting that whole numerator. So I can write it with parentheses. I will have to distribute. So what do I get? I get 3x squared minus 9 over 6x squared minus 10x minus 4. Alright, so I've essentially simplified it, but again, I want to look at factoring the denominator to look for restrictions, also to look to see if I can simplify this at all. I could also factor the numerator here, although I don't think anything's going to simplify. If you do factor the numerator, there's a 3 in common, and you'll be left with x squared minus 3. Which is not a difference of squares. In the denominator, there is a common factor of 2. So if you take that out, you'll have 2 times 3x squared minus 5x minus 2, which is again factorable. If you do factor that, then what do you get? (3x plus 1 times x minus 2 are the factors of 3x squared minus 5x minus 2. You can check that that is correct. Nothing simplifies here, but this is the factored expression. This is one way the answer could be given. What restrictions would we have if we were asked for that? Well, again, going back to the original denominator, the original LCD was 3x squared. 3x squared. 3 cannot equal 0. If x squared equals 0, then x is 0. Looking at this denominator in the end, if 2 equals 0, well, 2 equals 0 has no solution. If 3x plus 1 equals 0, then x is negative 1/3. That's another restriction. And I got this, a third restriction of 2. Oh. So again, you should know how to find restrictions always, but they won't always come up. They won't always be useful to a problem. But I'm going to keep emphasizing them. Let's do one more example. Here I have 4x over x plus 3 over 2x minus 6x plus 14 over x plus 3. So again, the LCD is pretty simple here. It's just x plus 3. So what do I want to do? I want to multiply by x plus 3, each term. And you notice I'm putting the factors in parentheses. Be careful about that. That is a good idea. It helps me to avoid things like forgetting to distribute negatives properly. whole idea of this, again, is to allow me to eliminate the denominators inside of the fraction. I look at each of these individual terms and simplify the denominators. So what am I left with? Up top, I have 4x. In the denominator, well, I have 2x times x plus 3 minus that whole numerator, 6x plus 14. So if you multiply this out, what is this? This is 2x squared plus 6x minus 6x minus 14. Okay? So that's 4x over 2x squared minus 14. Well, that's not really an acceptable answer. If you look at all of these, they're all divisible by 2. So what I have to do is factorize. I have 4x, whoops, move my paper, over 2 times x squared minus 7. And then what can I do? I can divide out the 4 and the 2. Left with the 2 up in the numerator, over x squared minus 7. Okay. That cannot be simplified any further. And again, I want to think about restricted values if I'm asked for that. Well, based on the original LCD, x could not be -3. When I look here for this expression, this does not factor any further, but that doesn't mean I can't find restrictions for it. If x squared minus 7 is equal to 0, then x squared is equal to positive 7. Very important that it's positive 7, because I'm going to take the square root in a second. If I were square rooting a negative number, I would get a non-real answer, which I don't really care about for restrictions. X is the positive or negative square root of 7. So these are my restricted values. This is my equivalent answer. All right. So hopefully that should make sense. Tell you what, I'm going to do one more answer at random, one more problem. I'm just going to make this one up on the fly. Okay. So we will say 3 over x plus 4 minus 5 over x squared minus 2x minus 24 all over, what do we want here? We'll say 3x plus 10 over x minus 6. Okay. One more example right here. So again, if I want to do this, I have to figure out my LCD. Well, I see these two distinct factors here, x plus 4 and x minus 6, and I see this factorable polynomial over here. So what do I want to do? I want to look and see how this factors. This is x plus 4 times x minus 6, because their product is negative 24, their sum is negative 2. Leading coefficient's 1, I know I can just do this really easily. So my LCD is x plus 4 times x minus 6, because that covers all of these factors. That's my LCD. So what I'm going to do is multiply each term by that LCD. So 3 over x plus 4 will be multiplied by x plus 4 times x minus 6. 5 over x plus 4, x minus 6 will be multiplied by x plus 4, x minus 6. And my denominator, 3x plus 10 over x minus 6, that expression will also be multiplied by x plus 4 times x minus 6. Now again, why am I multiplying by this LCD? It allows me to eliminate all of the denominators within this fraction. And I'm left with simply, I have to be careful here, I've used up most of my room. I have 3 times x minus 6 minus 5 over, in the denominator, well, this is already factored, 3x plus 10, x plus 4. So what do I have left to do to simplify this? Well, remember, we want to leave our denominators factored generally, so I'm going to leave that factored. Up on top, I need to distribute and combine the constants. I will have 3x minus 18 minus 5. So what will I have? I will have 3x minus 23 over 3x plus 10 and x plus 4. And again, I want to think about restricted values, so you got to look at everything that was in the denominator at any point. So in the original problem, the LCD was x plus 4 and x minus 6, which means that x could not equal negative 4 or positive 6. What else became denominator as I worked through this? Well, 3x plus 10 became a denominator. If I solve that, the zero of that is negative 10/3. So those are my restricted values. So again, hopefully this has made sense. Hopefully it helps you to understand the process of simplifying a complex fraction.